Uh, Hi, instructor. My name is Han Yan, and I'm here to present my semester scholar project for STAT 512. And my project topic is blood pressure necessarily and positively related to age? The type of the project is confirmatory observational study. My name is Han Yan from Purdue University College of Science, and I major in math. The date for today is 2021, April 26. For some introduction and background of this study, we all know that persistent high blood pressure can increase your risk of a number of serious, potentially life-threatening health conditions such as heart disease, heart attacks, strokes, heart failure, and arterial disease, kidney disease, and vascular disease. These are all life-threatening disease and is very dangerous after people get aged. When people get older and older, high blood pressure may be a huge problem and is concerned for the public health. The null hypothesis and alternative hypothesis for this study. The null hypothesis states that the age has no statistically significant impact on the blood pressure, while the alternative says that age has positive impact on the blood pressure and is statistically significant. This project, I want to set the blood pressure as a response variable and set age as explanatory variable because it's a confirmatory observational study. Sodium intake, heart rate, weight, physical activity are added to reduce the error. And for the data source I use in this study, the source of the data is available on DataWorld from downloading. The address is provided below, and similarly, the address of this is also on the summary page and our analysis process, and data is provided. The whole data is provided after the uploading of the presentation and summary page. It's attached in the Brightspace uploading mixture. So let's take a brief look of the dataset. As we can see, there's totally 54 rows and 6 columns in this data. And the response variable is marked with the right column. We can see that it's diastolic blood pressure. And the age, sodium intake per day, heart rate, weight, physical activity are explanatory variable. Among them, age is the primary explanatory variable that we want to explore and to test hypothesis on. The other 4 are risk factors in confirmatory observational study to reduce the error. So to help you better understand my R analysis process, because some of the code I use another name, a simpler name, I will introduce the name of the variables changes. The explanatory variables and response variables are explained below. So first, age x1. It means the age of the sample, calculated by the years after birth. Sodium intake x2 is the average sodium intake of 20 days at the most recent with unit milligram per day. Heart rate x3 is the number of the heartbeat in 60 seconds. Weight x4 is the body weight of sample with unit in kilogram. physical activity x5 is hours of physical activity per day calculated by the average of 20 days at most recent. And for the response variable y is blood pressure with unit mmHg. It's the length of the mercury the pressure can hold, calculated by millimeters. So let's start the preliminary analysis process. On the right side, we can see a huge scatter plot. It's a scatter of the whole data set. We can see that a positive relation is shown between the age and the diastolic blood pressure. Something else we can also observe is that when age is getting larger, it deviates more in the diastolic blood pressure. That might indicate a non-constant variance problem, but for this we need to see that on the added variable plots later in the later process. But that might be a problem that need to be considered. And for the other variables, we observe among the x variables, it means that among the primary variables and risk factors, we can see there's no much clear pattern between those x variables. That indicates that the multicollinearity problems might not be that serious. It might not affect the precision of the model. Okay, here's the residual plot of the single linear regression of each variable with y. And we can, although it's a little small, but I will explain it to you. The other three, x3, x4, and x5 shows no pattern between the residual and itself. However, x1, we can see a clearly huge fluctuation. Larger is getting larger and larger when x is getting larger. It prove our it indicates that the variance is getting larger when x is getting larger, indicating a potential non-constant variance problems, as we observed in the previous page. So after the preliminary analysis, the possible issues observed is that no obvious multicollinearity. 2, no obvious outliers according to the box plot. I didn't provide the box plot here because I provided on the R analysis process. We can see no obvious outliers. And 3, x1 age has significant non-constant variance violation. Its wave plot might show a clear positive pattern on the data. So as a confirmatory observational study, we first build model as the first order model will be x1 y equals to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus b5 x5. And we use this model to further examine the non-constant variance we observe in the preliminary analysis. The added variable plot is shown on the right side. We can see that for x2, x3, x4, and x5, the other variables, the risk factors, all shows that they have no clear pattern and relations with their residuals. And for the x1, it shows a clear positive relations. So a strong unconstant variance on variable x1 is observed. And follow the process of model diagnosis. Outlier checking is performed with RStudent method and LM influence method for checking Y and X outliers. The result says that no obvious outlier is observed through this method. And the output of the result is shown here. It's also on the page of the R analysis process. So the testing for influential points, here I use the Cook distance method for testing the influential points. The results says that no critical influential point is observed. And the fourth one, although we observe no clear pattern on multicollinearity problems on preliminary analysis, we need to use VIF method to prove that they have no relations with other variables among X. The result shows that since no excessive VIF value is observed, multicollinearity isn't an issue for this model. And after the model diagnosis, we want to select the models. Here I use the best sub method for model selection. And the key criterion I use to judge the model is the Press-P value. I choose the smallest Press-P value, that is the model when 4 X variables are present and that P equals to 5. The result is Y equal to B0 plus B1x1 plus B2x2 plus B3x4 and plus B4x5. Here we are at the point that need to fix the non-constant variance violation. And we need to use the method we learned in the MLR remedial procedure. So non-constant variance problem should be fixed with weighted least square method. Here comes a very strange thing that I went through while doing this project. It's that even after I used the WLS method, the AV plot still shows a strong relationship between variance. I have no idea, but I think the non-constant variance problem fixed a little bit, but not completely. Here's the added variable plots after the WLS method. The whole R analysis process is attached on the page of the R analysis. May I ask instructor on where did I do wrong? Because I still have no idea why I performed this WLS method and it does not work. And here comes the final model summary. I use a model that is dealt by the WLS method, though I know it does not kind of fix the problem. From the summary of the model, we know that for X1, it's the age. It has a positive impact on blood pressure, and it is statistically significant because the B1 is 0.9505. It's a positive number, and P value is far, far smaller than the significant value. So here comes the conclusion. Yes, age has significant impact on the blood pressure, even already considering the sodium intake, heart rate, weight, and physical activity. This indicates that there are some other variables in human body change with age that impact the blood pressure directly. 2. The age of the positive impact on blood pressure. Each year increase in age leads to 0.95055 increment in blood pressure. And that's it for my presentation. Thank you for your listening.